Okay, so vertical stretches or shrinks. We have a formula here that says you take the number that is the stretch or the shrink and you multiply it by the function. That's going to take for example, absolute value and either stretch it vertically or shrink it vertically. You see how with my fingers, if I stretch it vertically, I'm like taking my fingernails and I'm going up higher, faster. Or if I'm vertically shrinking, it's not going to rise up as fast, so it's wider. So that will occur when you take a function and you multiply the outside of it by some number. I like to think about it like this. Okay. Horizontal stretch or shrink is kind of the same concept, except we're going horizontal. So if I take my absolute value here and I want to horizontally stretch it, my fingers are going to go out. Horizontally stretching, they're going to go out. Or horizontally shrink it, they're going to go closer together because we're thinking left to right, shrinking. Horizontal shrink. The thing that's weird though is, horizontal is always opposite. So where for a stretch, for a vertical stretch, it's a number greater than 1. For a horizontal stretch, it's a number between 0 and 1. Because horizontal is always opposite and makes everything difficult. Less 2. For a vertical shrink, if we have a number between 0 and 1, a horizontal shrink is less than. I lied. Greater than 1. If it's a bigger number, it's actually a horizontal shrink. And then in the equation, you will see that horizontal is a number that is multiplied by the x inside of the actual function. So here's an example where we have -2 inside of the absolute value x, or 4 inside of the absolute value x, or 0.2 inside of the absolute value of x. It's inside. If I have a function, let me do this with my absolute value fingers. If I have a function and I am going this way and going this way and going this way and going this way, my fingers don't move all the way that way. Let's go this way. Let's say I'm talking about vertical shrink. If I'm vertically shrinking and I'm vertical shrinking, I'm vertical shrinking, I'm vertical shrinking, what's going to make my function go like this? A negative number. Is that a vertical stretch or shrink? What kind of transformation is a negative number? A reflection. So sometimes, like this one right here, that can't be a negative. Is that a negative or a spot? Oh, that is a negative. I know why. Never mind. So sometimes we might have a negative. That would be a reflection and a stretch or shrink. Why is this one not facing down, even though it's clearly negative? Kia? Yes, but it's still a reflection. It's what? Oh, it's on the inside. What does that mean about reflecting? What kind of reflection is it if it's on the inside? It's in the y-axis, so instead of the v being here, the v's here. Guess what? They look exactly the same. So that's why it's not down. It's this way. Okay. That's a really quick review there. Now we'll actually do some of this. Okay. We'll start with G. First thing that I want to do is decide what my parent function is. What's my parent function? Quadratic, x squared. And then I use my parent function points, and you are asked to graph the parent function and the new function. So I'll go ahead and plot my parent function points. I'm going to like dashed so that I can tell the difference between that one and the new one. Then we're going to list the transformations. I like to use tables when we have a stretch or a shrink. because for me it's easier to use the table than it is to try to envision all these stretches and shrinks plus translations and reflections in my head. So I'm going to use the table for every single one of these. 2x squared minus 4. What does the 2 do? So is 2 on the outside of the function, which is x squared? Is it on the outside or is it on the inside being squared? That is on the outside. The squared is not on the 2. If it were on the 2, how would I know from the equation? A little bit louder, I can't hear you guys. There would be parentheses. If it were inside, it would look like that. So since the squared is not on the 2, that is a vertical. So it's a vertical, this is how you write it, vertical stretch factor of 2. I know it's a stretch because vertical, the numbers don't change, and anything that you multiply by 2 gets bigger. So factor of 2, we're going to multiply the y's by 2. Then what's my next transformation? We have a minus 4. Is that vertical or horizontal? Is it inside of the function or outside of the function? It's vertical. It is not being squared. So this is a translate where down for units. So to my vertical side, to my y values, I will subtract 4. Then when I go to graph it, I do not need the first 2 y's, I just need the very last one, and I need my x's. Negative 314 doesn't really fit. Negative 24, here I'll do it in a different color though. We're going to do our domain and range in interval notation. So domain for quadratic is always all real numbers, negative infinity to positive infinity. And then for the range, we choose the lowest number, negative 4, and it goes all the way up to positive infinity. Now, if you have a question, you should stop me and ask. I guarantee if you have a question, probably 10 people in here have that same question and nobody's stopping me. So then I think nobody has questions and I go faster. Okay? So if you come up with a question at some point, just raise your hand, or if I'm not looking at you and I don't see your hand up, just say, hey, Ms. Griswold. And I'll be like, huh? Okay? All right, the next one, question B. This is quadratic. So I'm going to go ahead and fill out my parent function points while people are catching up. And plot my parent function. Now we need to list the transformations. So I like to do left to right. Doesn't really matter the order you list them in, but I'm going to do left to right. The first thing that I come to is a negative sign. Is that on the inside or the outside of the squared? Outside, so that's vertical. Negative means a reflection. So if you're not sure which way we're reflecting, it is going to be reflect in the, and then if you're not sure which axis it is, well, pretend something is reflecting vertically. So here's a XY chart. I'm going to reflect vertically. Which axis is this cute little heart reflecting over? The X. So reflecting vertically is in the x-axis. Notice how your teacher writes in the, even though I cringe when I write in the because it sounds so weird. if I have in the written down, then, and you decide, I'll just write whatever I want, you're probably not going to get full credit on a quiz. So if I write it this way, you should write it this way and correct your answers on your assignment as well if it's not written the same way. Okay? So reflect in the x-axis, that is vertical, so we're going to take -1 and multiply it to all my y values. And move on. What's my next transformation? 2. Is that on the inside or the outside? Inside. So that means it's horizontal. That is either a stretch or a shrink. But remember, horizontal is always opposite. So this is going to be a shrink. And the reason it's a shrink is instead of multiplying by 2, what's the opposite of multiplying by 2? What am I actually going to do with that 2? We're going to divide by 2. But here's the thing. I don't like division all the time. Sometimes it's okay. But it's not always that friendly. So instead of dividing by 2, instead of dividing by a number, we can multiply by something. So instead of dividing by 2, you can multiply by, what is that thing called? The reciprocal. So instead of dividing by a number, we multiply by its reciprocal, which is doing the opposite operation. So I'm going to multiply everything by half. And because I'm multiplying by half, when you write this, you write horizontal shrink by factor 1/2. So you're shrinking by multiplying by half. So you get -3 halves, -1, -1/2, 0, 1/2, 1, 3 halves. Then we move to the next transformation. What is the next transformation? Okay. Left 6, but I'm putting you all on the spot because you only did this yesterday, or yesterday, and left 6 is not correct. But I know you all wanted to say left 6. Do you know what it is? Oh, so basically the same thing. You just use the correct mathematical verbiage. Still, this number 6 is wrong. Gavin? It is 3. How's Gavin getting 3? Oh, there was this rule we talked about really quickly yesterday that says if we have a coefficient and a translation inside the parentheses, this is only for horizontal. You only have to do it for horizontal because horizontal, everything's opposite. If you have a coefficient and a translation in there, you have to factor out that coefficient before you can find the correct translation. So you have to factor out that 2 from the 6, which makes it a 3. All my other transformations are fine. It's just the translation, the horizontal translation, that will be messed up if you don't do that step. So this is a translate to the left 3 units, and then we'll go ahead and put and 1 unit down. That's our right. So in our table, we will be subtracting 3, not 6. We'll be subtracting 3. -4.5, -4, -3.5, -3, -2.5, -2, -1.5. And then subtract 1 from the y's, -10, -5, -2, -1, -2, -5, -10. I'll go ahead and add my domain and range, which if you didn't graph as fast as me, you'll still get your domain and range. The domain's all real, so I put negative infinity and positive infinity. The range goes all the way down to negative infinity, comes all the way up to -1, so we have a bracket at -1. Okay, when you're done copying that one or writing it down, figure out your transformations for the next one. Figure out your parent function for the next one, and then I'll jump up and catch it. So if you did this on a test, I would totally. That's fine. I'm just letting you know. So you're not like surprised if that were to happen. Okay. So next one, we're looking at parent function points. What is our parent function in the next one? This looks good. What is that parent function group? Sure. Yeah, the square root of x. Right. So when I go pick y values, I'm not going to pick any negatives. I'm going to pick things that I can square root, like 4 and 9. That's what I'm going to pick for my parent function values. Transformations. We have a 3. Is that on the inside or the outside? Outside. So that's vertical. I'm off the screen a little bit. Vertical stretch. Factor of 3. The 1/2. That's on the inside. See how it's under the square root? So that's a horizontal. But what? Ooh, I heard both answers. What am I going to multiply by when I go and multiply? I'm going to multiply by 2. So that tells me this is a stretch. It just looks weird because it's a half when it's inside the function. And we write factor of 2. You write what you multiply by. The words in the table match. The equation is the thing that doesn't match. The words in the table match. How about translate? Translate. Right. 1 is not correct, but I see where you were going and you were on the right track. It's going to be 4, because when you factor out a half, x half of what ends up being 2? Half of 4 is 2. So if I were going to distribute it back in, it would distribute 1/2 of 4 is 2. So it's actually 4. But I am proud of you for knowing you had a factor there. So we'll make our table. Oh, I didn't graph my parent function. And then the new function is going to be 4, 0, 6, 3. Where's my 6? 12, 6. I think I can use it to just kind of have an idea of how high to draw that, but there's no way I'm graphing 22, 9. Oh, I wasn't on the screen. Sorry. For this one, the domain goes to the left, starts at 4, goes all the way to infinity. The range goes all the way down to 0, goes all the way up to infinity. For time purposes, not going to do all of D. Let's just talk about what the transformations would be in words, and then we'll move on to the next question. You know, you have to graph both. You know, you don't have to in your notes, but you have to graph both. Okay. I mean, parent and not parent. So let's just talk about the transformations. What would the 1/2 do? Inside or outside? Outside. So vertical. And vertical is like the number that you'd expect to be. So if I'm doing half of something, it is smaller, shrink. Back to what's the 4? Horizontal, shrink, because what's my factor? 1/4. And then the subtract 2 would be translate 2 units. Is it vertical or horizontal? It's vertical, so that would be down. And what shape is this one? A V shape. It's absolute value. So you'd have a V shape. So when you're done, if we're, no, you won't reflect it. Just kidding. All right, let's do the hard part. All right, get your focus on. You ready? Focus on. Okay, so I'm going to sum up like all of Algebra 2 right now. Here we go. Because did you guys do transformations last year? And if you did them in every single chapter. Yeah, so that's one reason why I'm going kind of fast. This was always the part that students struggle on, is taking the information and correctly writing the equation. So I'm going to try to help you as good as I can. What I want to put at the very top is anything that's vertical. You will have a function, whatever that function is. I'm just going to use f of x to represent that function. And anything that's vertical, you will do stuff to the outside of that function. Anything that's vertical, you will do stuff to the outside of that function. If you have horizontal transformations, you're going to have stuff happening on the inside of the function. And if you have something like this, if you have it on the inside, this means only replace the x in the equation with that parenthesis and whatever's going on the inside. So this is a substitution type thing. This is a replacement. So this sums up all of the different things that we're doing. They're either vertical or horizontal. Now, if it's a vertical stretch, what would you do to the outside? If it's a vertical stretch, you would do what operation? Stretch. That's a multiply. If it was a vertical translation, what would you do on the outside? Add or subtract. If it was a vertical reflection, what would you do on the outside? What's reflection? Negative sign. So you do any of that stuff on the outside. You're going to do the same stuff on the horizontal, but it'll just be on the inside. And opposite. Maybe we should write down. Opposite. All right. So order does matter for these. Most of them matter. Question A, f of x equals x. Super easy equation, x. Vertical stretch by a factor of 2 followed by a translation 1 unit up. So since order matters, I like to do the first half as a separate equation and then use that to find the second half. So I kind of separate it by the words followed by. My first half is not going to be my final equation. It's kind of like halfway through. So I'm going to name this first half the h of x equation. The second one I'm naming g of x. The reason why I'm naming it g of x, because in the directions it says name it g, which means g of x. So it's telling me to call it g. It's this orange one that is not in the directions that I'm just kind of using as organization. So if we have a vertical stretch by a factor of 2, I'm going to take my equation and I'm going to take whatever the function was, it is x, and I'm going to do what to it? Stretch by 2, what am I going to do to this original function x? Terry? Multiply by 2. Put a 2 in front, is that what you said? Yeah. Okay, so my h of x is 2x. Those brackets are just saying, like, that's my original function. Okay? Same thing as a parenthesis. So that's my h of x. That's halfway through. So now we're going to use this and use this function to translate 1 unit up. So my g of x, this is a vertical. Up is vertical. So vertical, I'm going to write my function inside, 2x, and I'm going to translate 1 unit up. What will I do to that function? Plus 1? On the outside, right? Now if I take 2x and I add 1, they're really, I don't need those brackets. They don't really do anything, so just get rid of them. And I have g of x equals 2x plus 1. So you might have been able to do that without all my steps, but then they get complicated. So that's why I'm showing all of these steps, because they get complicated, and I've taught pre-calc and I've taught algebra 2. This is the part where people struggle. Doing my best to give you as much as I can. Next one, our function is next one is f of x equals x squared, and we'll use the first part as our h of x, translating 3 units down. That's my halfway function. It's going to be 3 units down. Is that vertical or horizontal? That's vertical. So I will go ahead and take my x squared in brackets, and 3 units down is going to go on the outside of that function. And we'll just simplify that a little bit. H of x is x squared minus 3. That one's pretty easy. So now my g of x has the second part. Vertical shrink by a factor of 1/3. Is that on the inside or the outside? Vertical shrink. It's the outside. Okay, so then I need these brackets, and I'm going to put h of x inside the brackets. I'm putting my last equation I had, x squared minus 3, inside of those brackets. And then that 1/3, did I say 1/2 or 1/3? 1/2, 1/3. What is it? I wrote over it. It's 1/3, I'm sorry. 1/3 is going to go on the outside of those brackets. So when I say 1/3 of the entire function, that's not just 1/3. Now I've got g of x equals 1/3 x squared minus what? 1.